Hi, I'm Matt Bremer. If you're like me, you collaborate regularly with remote colleagues. And this collaboration usually involves knowledge sharing that is grounded in data and visualization. This is a paper for researchers eager to take on challenges associated with supporting this form of collaboration. Now, this illustration nicely captures the reality of collaborating around visualization in organizations today. We see multiple people, some of them are co located, others remote. And together they're trying to make sense of data. They're asking questions, forming hypotheses, making decisions. In other words, this is collaborative and multimodal data analysis. There's visual aids, collaborator voice and video, and gestural communication. What we don't see illustrated, however, is the increasingly important role of AI in these situations, as well as new interfaces and extended reality display technologies, as well as the technological asymmetries between participants resulting from these developments. Now, exploratory data analysis isn't the only activity in which people collaborate around visualization. Essentially, what we care about in this paper is any synchronous experience involving the presence of data visualization artifacts or interfaces and multiple people in remote or hybrid configurations. Other activities that we consider in this paper include divergent ideation, where the goal is to generate new data, new ideas, such as in the domain of industrial design or product design. Data-rich presentations, such as when a public relations team at a publicly traded company gives a quarterly earnings presentation to their investors. Joint decision making, when it's grounded in data, where the goal is to negotiate, ideally reach some consensus, or maybe it's just at least a state of productive dissensus. And real-time collaborative data monitoring, such as what we might see in emergency response or in high-performance athletic training. Now, collectively, these five types of activities form the scope of the challenges that we discuss in this paper. And these challenges fall under four themes. This includes technological challenges, which has to do with the multimodal interaction affordances and display capabilities of computational devices through which people collaborate, as well as social challenges, challenges relating to AI assistance, and challenges relating to the evaluation of these experiences and applications. We identify four open research challenges in each of these categories, resulting in a total of 16 challenges, each named with a succinct verb and noun phrase like you see here. And collectively, the identification of these challenges, along with a reflection on how they manifest across the five types of activities, represents the primary contribution of this paper. Now, before I speak to specific challenges, you might be asking, why should you listen to me? And how did we arrive at these challenges and activities? Well, this paper integrates many perspectives with a long author list that is hierarchically organized. So Maxime, Christophe, and myself served as overall editors of this paper, and we coordinated with a team of section leaders who in turn synthesized insights from groups of subject matter experts. It represents the outcome of a Japanese National Institute of Informatics session, Shonan meeting on the topic of synchronous presentation, collaboration, and education with remote audiences. And this was held over the course of 4 days in the summer of 2024, where 27 of the authors met in person, with two more joining discussions remotely. This paper is also the outcome of the Mercado workshop, which was held at IEEE Viz in 2023 and once again in 2025, where Mercado stands for Multimodal Experiences for Remote Collaboration Around Data Online. Now, to plan our Shonan meeting, we wanted to bring together disciplines. And while HCI and visualization are certainly well represented in the author list also includes experts in the CSCW, user interfaces, and extended reality. Now, collectively, we have experience designing and evaluating collaborative applications across many different domains, from business intelligence to education to emergency response. We came from 4 continents and 9 countries, representing academic institutions, nonprofits, industry labs, all the way from early career researchers to senior professors. Another question you might have is, what about those seminal collaborative visualization papers? Why did we feel a need to revisit this topic? In particular, there's a paper by Petra Eisenberg and colleagues that identifies challenges and proposes a research agenda for collaborative visualization. And this followed an earlier paper by Jeff Hare and Manisha Grawala reflecting on collaborative visual analytics. However, neither of these focus specifically on synchronous and remote collaboration, with Jeff and Manisha's paper, for instance, focusing on asynchronous collaboration. Moreover, it's been 15 and 18 years respectively since these papers appeared. You might say that a lot has changed. Now, one change is the growing feasibility of remote and hybrid work, certainly accelerated by the COVID-19 pandemic. Another is the rise of AI assistants, both in collaboration tools on the one hand and in data analysis tools on the other. And this assistance remains siloed within these tools. For example, your Zoom AI doesn't coordinate with your BI tools AI. Now, some of this disconnect is simply because of the tools are built by different vendors, but some of this is also just an open research challenge. Another change is the increasing receptivity in organizations to extended reality technology for supporting remote collaboration. Now, with these changes in mind, we seeded our discussion with an initial topic list, which in turn was the outcome of our 2023 Mercado workshop. We split off into breakout discussion groups over the course of 4 days, and we continued these discussions in weekly Zoom meeting discussions over the course of 4 months. And throughout this time, the groups generated several different types of artifacts. We had whiteboards, bibliographies, slides, and notes, both human generated and AI generated. Now, the groups also designated some members to take on more of a top down perspective, reflecting industry trends, the activities that we identified, and their lived experiences as researchers. While others in these groups took on more of a bottom up perspective, which largely meant collecting and annotating supporting references. Now, as a result of this process, we arrived at the identification of those 16 open challenges that I previewed earlier. And for each of these challenges, we contextualize them by referring to these 5 activities that we mentioned. We pair each challenge with at least one near-term research opportunity. Now, in the time that remains, I'd like to highlight 4 example research challenges and opportunity combinations, one from each of these themes. And the 4 that I exemplify do not imply that they're any way more important than the other challenges, but merely representative of the scope of the challenges discussed in this paper. The first challenge I want to highlight is a technological challenge, and that has to do with anticipating technological asymmetries. Here, collaborators want to work together, but they also want to use different devices having different display and interaction design capabilities. We're already seeing some XR research prototypes like Dash Space in the Spatial Straits framework embrace device heterogeneity, as well as some commercial tools like Flow Immersive do this. Now, the research opportunity here is to study the effects of this device interoperability and heterogeneity on collaborative dynamics, on the activity goals of collaboration, considering both XR as well as mobile and large displays. Next, I'll highlight a social challenge, one of supporting dynamic roles, in which collaborators might shift between being a presenter or a viewer or decision maker, all throughout the same activity. Here, a research opportunity is the design of studies that explicitly cast participant roles and change them throughout a study, or those that deliberately recruit those at varying levels of subject matter expertise. When it comes to AI-related challenges, I want to highlight this first one that is about the need to select appropriate interaction paradigms for AI assistants when collaborating around data. For instance, what if one of the remote collaborators here, instead of being a person, was an AI assistant? Is this assistant a scribe? A mediator? Are they a fellow analyst, perhaps? Do they generate new visualization content for us? Or just annotate existing ones? Are they relegated to command and response information retrieval, or should they do something more? So research opportunities here include comparing proactive and explicitly invoked AI assistants in these scenarios, as well as comparing the visibility of this assistance. Does every collaborator here in this picture benefit from the same assistance, or just those that require some missing context filled in? And finally, one evaluation challenge I want to highlight has to do with the logistics of observing remote and synchronous collaboration around visualization. So when we instrument our research prototypes and design our studies, we collect the right data. Now, one opportunity here is to extend and adapt existing visualization interaction logging tools used in many studies, such as the Revisit platform, for instance, so that they could document these more collaborative scenarios. Or to extend Koshadal's recent framework for logging synchronous co-located ideation to remote activities involving visualization. So in closing, we invite researchers to expand on our set of challenges and to look to other activities involving synchronous and remote collaboration around visualization beyond those 5 activities that we profile in this paper. It's also worth explicitly stating at this point that despite having a bottom-up perspective represented across these challenges, we're in no way claiming that this paper is an exhaustive literature review. Nor are we contributing a new universal theoretical framework on collaborative visualization here. Getting 29 authors to do so would probably require a lot more discussion, and that's where we turn to you. We invite you to join our Mercado research community and participate in future research workshops and seminars. Now, beyond researchers, we also hope that practitioners and tool developers take note of this paper, particularly when it comes to accommodating device asymmetries and unifying the AI assistance between collaboration tools and our data tools. And lastly, we also direct this work at policymakers and funding agencies, as the activities that we're profiling are central to domains like public health, climate science, education, and urban planning. So ultimately, by taking action together, we can design, evaluate, and deploy collaborative systems that are ready for the future of remote data work. Thanks.